Hello, my name is Julie, a member of Team 12, and we would like to present our project, NASA Psyche Mission Space Object Virtual Reality. Our team has developed an alpha version of our virtual reality, which immerses the user in an interactive learning experience. The user starts out on the asteroid Eros, which we selected due to the wealth of information readily available from NASA on the topology, rotation, mass, color, and much, much more. This data has assisted us in creating a more realistic virtual reality, and the addition of the SPICE toolkit, which we continuously are learning more and more about, will assist us in using specific data points to create a hyper-realistic experience in regards to celestial and mission-related positions in the solar system. We are developing an astronaut's form that the user's controllers and headset will attach to in order to interact with the environment. Additionally, there are locations around the map where the user can interact with widgets that have information such as interesting facts about the mission and NASA's ongoing projects. The user experience has been honed to mitigate virtual reality related motion sickness through the implementation of blinders and linear motion during jumps. We have emulated moon-like gravity for jumping, since the user would fly off into space if they actually tried to jump on Eros. Our project is optimized for smooth operation using the Oculus VR headset and controllers, so we currently recommend using one for experiencing our alpha version. Here is Ryan, and he will discuss the project's structure, flow, and features.
Our project is structured fairly typically as Unreal Engine games go. The brain of the system is made up of the game instance and the game mode classes. These keep track of short and long-term data and are accessible by all the components in and behind the scenes. The experience is divided into maps or levels, each taken from different parts of Eros or from space near Eros. The user interacts with these scenes by possessing the character in pawn. Because we are developing a VR experience, the body is handled by the player character class, and each hand is an instance of the pawn class. Information is displayed to the user via UMG, Unreal Motion Graphics. The engine imports all of our collected assets, from images to audio files and 3D models. Our VR experience uses key events from the Near Schumacher mission to create a simple story that unfolds as the player explores Eros. We are recreating a different perspective of Eros for each key event chosen, and multiple systems dictate this flow. Users are guided by a timer that prompts travel to the next scene upon completion. At any point, they can manually choose where and when they would like to go using a scene selection tool. Portals in each scene will take the player to the subsequent scene whenever they are ready. Users have several ways of interacting with and learning about Eros and the Near Schumacher mission. Objects such as the Near spacecraft, loose rocks on Eros, and mission artifacts are transported out of space and time for the user to scan for information and even pick up and hold with their VR hands. Data points populate the environments with audio logs, text, and videos relating to Eros and the mission. Users will have several ways of interacting with and learning about Eros and the Near Schumacher mission. Objects such as the Near spacecraft, loose rockets on Eros, and mission artifacts will be transported out of space and time for the user to scan or information or even pick up and hold in their VR hands. Data points will populate the environments with audio logs, text, and videos relating to Eros and the mission. Now here's Eric to talk about some of our project and engineering practices.
Hi, this is Eric from Team 12, the NASA Space Object Virtual Reality Project. For the construction of our program, we used Taiga as the website to monitor and create our sprints. We were able to formulate the tasks of our sprints from the meetings that we had with our sponsor, prioritizing what we felt the project needed. After investigating and deciding that our project was going to be focused on Eros and the Near Schumacher mission, our first sprint was based on getting the foundation of our program constructed in Unreal Engine, along with collecting fundamental data to get things started. Our second sprint mostly involved adding details such as textures, a 3D model of the asteroid, the Schumacher probe, and collecting real data to be presented to the user. Our third sprint was focused on adding details to those various items that we added in the second sprint, such as texturing, additional VR setup, along with and also started to get a storyline together so that the user can have a story-like experience in the program. Also, after long discussions with our sponsor, we realized how important it was to get SPICE implemented into our program. So we dedicated our fourth sprint to learning for the team to learn how to drive data from NASA SPICE software. Our final sprint was focused on fine-tuning all of the previous work into a workable demo and some additional details that would make it presentable to our sponsor.
Hello, my name is Dakota from Team 12 of the NASA Space Object Virtual Reality Project. For our project, we created blueprints which serve as a visual scripting tool for C++ code to implement various parts of our project, such as locomotion, physics, widgets, and inserting visual and audio effects into our project. We began our project with a template project that includes various built-in functions for teleporting, looking around the scene, and grabbing objects, and built upon that template to include key requirements such as walking with the motion controllers and being able to throw objects into space that simulate real physics. On top of that, we have also included a third-party plugin that simulates directional gravity on a planet. However, it has yet to be implemented within our current maps. As far as our project goes, I believe we are on track with the project plan, as we have been consistently completing the tasks on our sprint board, and our sponsor has been impressed with the progress that we have made thus far. We also created meshes within Maya and Blender, two 3D modeling applications, and created meshes for the models in our project, such as rocks, and cut out portions of our asteroid body. We have also used these applications to download resources available from NASA and use those models to convert them into .fbx files into Unreal. And now here's Nathaniel to discuss our repositories.
All right, in this section, we're going to go over the different repositories that we use to create our project. The first one we're going to cover is GitHub. So we used GitHub because it was really easy to push and pull and commit different code that we were using into this repository. If we were working on different sections of the project, it was real easy to combine those all together in the end. So going over what we've got in here, you can see this, what's reflected in the website is reflected right here on my PC. So one of the first ones is the Blender files. In here, we kept a lot of the different files that we were using for our 3D models, mostly converting a lot of maybe .blend files into .fbx files to be used in Unreal Engine. So then we also have in here some CSpice and SpicyPy that was used to pull out some information from different kernels. We kept some information in there, and then you see some of these ones with our names on it. That was when we went through some of the lessons on how to use SpicyPy. And then obviously the meat and potatoes here is the NASA 3D Psyche viewer. That's going to be where our main project has been held. We use Unreal Engine to build our project, and you'll see like what's covered here in content is the same structure that can be found here in the Unreal Engine. All right, and so for our second repository was our Google Drive. In here, this was a lot more of our paperwork side of the stuff that we were doing. So in here, we do our meeting minutes. These are all the different meeting minutes from our with our sponsor, and then we also had some meeting minutes, our Scrum stand-up meeting minutes for our team personally. Also, we kept some things such as a copy of our project timeline, different brainstorming things that we went over, just a lot more of that paperwork side of stuff. All right, thank you so much for watching.